Hi, this is Mrs. LaBarbera. This is Physics Chapter 11, Wave Behavior, Video 5. Today's topic is Doppler effect. The objectives are: know the definition of Doppler effect, understand how frequency and wavelength undergo an apparent change due to relative motion of a source and observer, be able to determine whether or not an observer will experience Doppler effect, be able to determine whether a frequency or wavelength perceived by an observer will be greater or smaller than those produced by a source. Doppler effect can be described as the effect in an apparent shift in frequency or wavelength produced by a relative motion between the source of the wave and the observer. Let's take a look at this animation. Okay, as the car is at rest, you perceive a frequency. But as the car moves away, the wavelength is increased relative to you. So as a result, you will hear a downward shift of frequency. As the car approaches you, the wavelength is decreased. As a result, you will perceive an upward shift in frequency, like the sound is getting higher and higher. And as it moves away, the sound is getting lower and lower. I'm talking about the tone, not the loudness. It happens as it comes toward you, there are two things happen. It's getting louder and louder. Also, the pitch getting higher and higher. As it goes away from you, the pitch getting lower and lower, and so is the sound getting softer and softer. So there are two things. Doppler effect is the pitch, not the loudness of the sound. Explain the effect of Doppler effect. The Doppler effect is observed because the distance between the source of the sound and the observer is changing. It doesn't have to be the sound. It could be any wave. So the source and the observer, if the source and the observer are approaching each other, then the distance is decreasing and the wave is compressed into a smaller distance, as you can see. So the observer perceived the sound wave reach him or her more frequently. So that means pitch is higher, wavelength is decreased. But as the source is moving away, the observed phenomenon is that the wavelength increases. As you can see, the wavelength is increases. That means the wave reaching you is less frequent. So you perceive a lower pitch for sound. Doppler effect is the perceived change in frequency and wavelength of the wave. What does that mean? Perceived means what you observe, but you observe the phenomenon, but not actual happening. Let's take, this is the original sound. So this sound has certain frequency. Okay, say frequency, I don't know, is 1000 hertz. Okay, so this is when you are at rest and the source is at rest. So no Doppler effect is observed because there is no relative motion. Suppose in this case, there is a Doppler effect. As you can see, the front of the wave get compressed and the back of the wave is elongated. So this is perceived Doppler effect. What you perceived is the higher pitch for sound is, if you are in front of the wave, you will hear the pitch get higher and higher and the wavelength get shorter and shorter, even though the source is vibrating with the same frequency as the first one. So the source is vibrating with the same frequency, but what you perceived, what you observed is shorter. So Doppler effect is observed phenomenon. It's not what the source of vibration did not change. It's what you observed has changed. Okay, so this is Doppler effect. If the source is moving at the speed of sound in air is about 340 meters per second, this is called Mach 1. Mach 1, that's a Doppler effect when the source of the wave is traveling at the speed of sound. What happens when the source is traveling faster than the speed of sound? And that is producing this wave is called a shock wave. The result of shock wave is called sonic boom. You will hear a loud sound. This is again, in all these cases, the source is vibrating with the same frequency, but observed frequency is different. That's called a Doppler effect. Let's see, Doppler effect of sound. It's shock wave and a sonic boom. So if a moving source of the sound wave at the same speed as the sound or faster than the sound, then a shock wave will be created and sonic boom is heard. So here is a short video.
There it is. There it is.
Okay, so you heard a sonic boom. Doppler effect of light is blue shift and red shift. So human eye perceives the light wave of different frequency as different colors. The lower frequency we can see red, and the highest frequency what we see is blue or violet. Due to Doppler effect, the apparent color of an approaching star source is shifted toward the blue end of the spectrum. If the light is approaching you, well, if the light is moving away from, the star is moving away from you, you perceive it as red. So here is approaching you, blue and red. It's called blue shift and red shift. So that's how we know the universe is expanding due to red shift of stars. Applications of Doppler effect. First, we are most familiar with how the police catch anybody speeding. What they do is they use a radar gun. So when a car is at rest, the frequency emitted is the same as the received frequency. If the car is moving toward the source of the radar, the reflected wave would have higher frequency. The greater the car speed, the greater the Doppler shift. Similarly, if the car is moving away from the source of the radar, the reflected wave have a much lower frequency. So if there is certain speed, so you're supposed to get certain frequency higher. If you're above that or lower above certain frequency, that's how the police know you are speeding. Doppler effect is also used in airport and weather stations. So how the airport know the plane is coming, right? They send radar waves, and that wave will be reflected by the airplane or by the cloud to determine where the plane is and what location and what is the speed it's moving. Similarly, for the clouds. So here's a radar. You can see the dot over there. So that's the Doppler effect application. Let's do a couple of examples. So a police officer's stationary radar device indicates that the frequency of the radar wave reflected from an automobile is less than the frequency emitted by the radar device. This indicates if it's less, then that means the two observer and the source are moving away. So they are moving away. The car is moving away from the police officer. Another example. So the police car traveling at a speed of 30 meters per second sound its siren, which has a frequency of 1000 hertz. So as the police car approaches the stationary pedestrian, the pedestrian detects the siren frequency of, because the car is coming toward you, you will perceive a higher frequency. So there is only one answer with higher frequency, which is 1.1 times 10 to the 3 hertz. That is when it's coming toward you. That's it for today. Thanks for watching.